Foundations of Amateur Radio. The other day we were aligning an antenna for a contest. It had slipped on the rotator pole during a recent storm, and when the rotator was set to 0, it was pointing somewhere southeast. Not ideal if you want to point your antenna at a particular station. The topic of the direction of north came up. There was vague hand pointing, some mobile phone compass magic performed, and north was arrived at. I asked if that compass took into account magnetic declination, which in turn was met with blank stares. So what is magnetic declination and where is north? It's likely that in school your first physics lesson was around magnetism. Playing with magnets is an easy way to start the conversation around science. One thing you learn in school is that opposite magnets attract, a north pole to a south pole and so on. A compass is a simple magnet with a north and a south pole. So the north pole of the compass is attracted to the south magnetic pole of the Earth. This means that the Earth's north magnetic pole is currently at the bottom of the Earth. Also, while we're on the subject, the magnetic field lines that leave a magnet are defined as being the north pole of that magnet. So, on top of the planet, the magnetic field lines enter the Earth, and at the bottom of the planet, they leave the Earth. That definition of north and south was the first to be used, and it was pretty successful in getting sailing ships all around the globe. Since then, the definition has changed into defining the poles as the points around which the Earth rotates on its axis. The North Pole is the one on your left as you face the rising sun. So, the North Pole that you and I talk about in day-to-day conversation refers to an imaginary point where the Earth rotates around you, and you stay still, ignoring for a moment that the Earth is hurtling around the Sun, and the Sun is moving around in the solar system, and the solar system is moving in the Milky Way galaxy, and it's moving inside the universe. Turtles, all the way down. In case you're wondering how fast you're moving while you're standing still, it's in the order of 360 kilometers per second, in relation to the cosmic background radiation. By the time you finish this, you'll have moved about 100,000 kilometers from where you started. The subtle difference between the definition of north being related to the magnetic pole and the rotation axis means that there is a difference where your compass points and where north is. You probably already knew this. You might not know that the amount of distance between both the magnetic poles and the rotation poles changes over time. The magnetic poles of the Earth are constantly moving. That's pretty straightforward, but there's more. The Earth's magnetic field isn't pretty. It's not all straight lines and unicorns. It's messy, very messy, and the mess is moving. Normally there's a new map published every 5 years, but sometimes that's not enough to account for the movement. For example, early in 2019, a new map was published out of sequence to account for changes that were larger than expected. Why the map, you ask? Because the field lines are not straight. You find all manner of weird shapes and swirls. This means that wherever you are on Earth, your compass is pointing in a different direction, because it's not pointing at the magnetic pole. It's aligned with the magnetic field line, which could be as much as 20 degrees off, in either direction. So 40 degrees error could make you completely miss Australia as you're sailing around the planet. If this is beginning to sound a little familiar, you might consider our Sun. Every sunspot is a magnetic pole. They come in pairs. A magnetic north pole, where the magnetic field leaves the Sun, and a magnetic south pole, where it enters the Sun. If you've come across the impact of the Sun on radio communications and the ionosphere, you already know that the Sun is a turbulent place. Sunspots come and go. They move around. There's cycles within cycles, solar minima, maxima, pole reversals, lots of stuff that makes this a variable feast. The Earth is doing this too. Not as fast, not as hard, not as big as the Sun, but measurable, and a rich source of research for geophysicists and geologists, since we can even figure out that the magnetic field on Earth reverses itself, has done many times, just like the Sun. So next time you get the question, where's north? Check out the magnetic declination map for your location. You might be surprised where your compass is pointing. It's almost certainly not north. I'm Ono, Victor Kilo 6, Foxtrot Lima, Alpha Bravo.